So in this video, we're going to talk about how you can find a vector orthogonal to another vector. So let's say we want to find a vector orthogonal to 3, 4. We know that A dot B is equal to 0 means that A and B are orthogonal. Or in other words, they're perpendicular. So that means if we want to find a vector orthogonal to 3, 4, then some random vector with entries, let's just say x and y, dot 3, 4 should equal to 0. And so if we take that dot product, it's going to be 3x plus 4y, and it's going to be equal to 0. There are infinitely many solutions to this equation because there are infinitely many orthogonal vectors. So we can just choose some arbitrary value for one of these entries. Let's just say let x equal to 4. This is one of the solutions. Then we would get 3 times 4, which is 12, plus 4y is equal to 0. That means 4y is equal to negative 12, and that means that y is equal to negative 3. And so one of the orthogonal vectors is 4, negative 3. And we want to verify this solution to be sure that we've done it correctly. And how you can do that is if you just take this vector we found, 4, negative 3, and you take the dot product with the vector we had from the start, which was 3, 4, it should give you 0. So let's just find out what this is. 4 times 3 is 12, and negative 3 times 4 is negative 12, which is 0. So that verifies our solution. We can take this one step further and do a 3D vector. So now we have 3 entries, and we want to find a vector orthogonal to this one. So the procedure is exactly the same. We take a vector x, y, and now we'll just add z. And we take the dot product with this vector 1, 2, and negative 1. It has to equal to 0. So the dot product here would give us x plus 2y minus z is equal to 0. And like before, we just let x equal some number. Now we let x and y equal a certain number. So we'll let x equal 1 and y equal 1. This is quite easy for us to work with. So we'd get 1 plus 2 minus z is equal to 0. Solving for z gives us 3. So these are our entries for the orthogonal vector. So we'd get 1, 1, and 3. That's an orthogonal vector. We want to verify the solution like before. So it's 1, 1, 3. We take the dot product with the vector 1, 2, negative 1. This should give us 0. 1 times 1 is 1, 1 times 2 is 2, and 3 times negative 1 is negative 3. And if you add those all up, you'll get 0. So that verifies our solution, and it shows you how you can do this in 3D.